All right, today's warm-up is brought to you by the letter C. By the letter C. C for cookie. It's good enough for me. All right. 1/2 cycle of a sinusoid is given at right. Did everyone see it at right? Did anyone miss it? It's in pink. Okay, I highlighted it for you. Write two equivalent equations for it, one in terms of sine and one in terms of cosine, and at least one of those two with the negative amplitude. That means we could put both of them with the negative amplitude if we want, right? At least one or more? Okay. How'd y'all start? We have a half cycle, right? Did anyone complete more of the graph, like extend the graph out and draw more of it? Anyone do that? Because you could do that. No one did that? Okay. That's not a bad idea. We have three values there. If it's a half cycle, this has to be an axis point. This, I guess, is a low point, and this would be an axis point. Now, because it's a half cycle, you could figure out very quickly what the period is, right? Because the period is defined to be the length of one full cycle. What's the length of this half cycle? That is, how far is it from 1 pi-7 to 5 pi-7? 4 pi-7. You do the right minus left. So if 4 pi-7 is a half cycle, what's the length of a full cycle? 8 pi-7. So the period is 8 pi-7. You find the half period and you double it. If I had given you just a quarter cycle, you would find the distance of the quarter cycle and quadruple it, right? So on and so forth. All right, so if a half cycle is 8 pi-7, we can immediately, once we find our period, we can find the b value. Remember, you get the period from the graph, and you need the b value for the equation, which is what we're going to kind of look at today. If the period is 2 pi over the absolute value of b, then b is going to end up being 2 pi over p. You can exchange them in the equation. Same equation, we're just using it a little bit differently. So our b value is going to be 2 pi divided by 8 pi-7. Well, that's a complex fraction, so stay, change, flip. We get 2 pi times 7 over 8 pi, and good things will happen here. What happens with your pi's? They divide out. And then 2/8 divides out to give you 1/4, so you end up with 7/4. There's the b value. All right, now that we have the b value, I guess we have most of the equation, maybe, or maybe not. What else do we need for the equation? The equation is a, b, c, and d, right? So if we have our b value as 7/4, the c value is going to depend upon whether we call it sine or cosine, or negative sine or negative cosine. So we'll hold off on that. But I can figure out the amplitude and the vertical shift. What's the amplitude here? Can we figure that out? 5? Why 5?
It shifted up 1. So.
Perfect. You said it shifted up 1. The sinusoidal axis is running through the axis points, and the amplitude is the distance from the sinusoidal axis to either the high or the low. How far is it from 1 to -4? 5. It's 5 units. So that's the amplitude, 5. And the sinusoidal axis itself is the d value, right? It shifted up 1, you said, so that's our d value. The d value is 1. Okay, so now that we have that, we can go ahead and get the template for our equation. We do need to give our equation a name. What do you want to call the equation? What name do you want to give it? Billy, okay? So how about Billy of x, okay? We'll call one of them Billy of x. Now let's go ahead and decide if we want to do a sine or a cosine. Let's start with sine. Good. So I'm going to have the amplitude, which is 5. I'm going to have a sine of parentheses. My b value comes next, which we found was 7/4. Parentheses, x plus or minus something, and then my d value is +1. So there's your template. We gathered all the information. We dropped it in there. Now all we have to do is figure out the phase shift. Positive sine starts where? High, low, or axis? Axis. And it's axis going up or axis going down for positive sine? Going up. So now come to your diagram. Do we have an axis point going up labeled? Yeah, if you were to extend it out here, this would be, oops, not like that. this would be going up, bless you, and this would be going up, going that way. So if you go over to 5 pi sevenths, you're actually on the axis heading up, aren't you? So if I shift it over from the y-axis to the right to 5 pi sevenths, that should work. Is that going to be a minus or plus 5 pi sevenths here? Minus. Good. There's a positive sign. Got it. If you wanted to do a negative sign, what can we call the negative sign function? We don't want to call it Billy anymore. That'd be too confusing. Bob? Oh, Bob. Oh, look, Billy Bob. Nice. A negative sign would be negative 5 sine. 7/4 would stay the same. It would be x plus or minus something plus 1. But negative sign, we're looking for an axis point not going up, rather an axis point going down. Where's an axis point going down? Pi sevenths. So would it be plus or minus? Minus. Good. I need to get to the right. So I wrote one for positive sign, one for negative sign. Let's go ahead and do one for cosine. What's another country name we can give for cosine? Billy Bob and what? I heard a J word. Joe. Okay, Joe of X. Joe of X. Billy Bob Joe. I'm going to leave a little space in the front for a positive or negative, because I'm not sure yet if I want to do a positive or negative cosine. So I got 5 cosine of 7/4 parentheses x plus or minus something, close, close, plus 1. Now for a cosine graph, cosine starts where? High axis or low? High. And a negative cosine starts low. Look at our graph over here. Do we have a high point or a low point labeled? We have a low point showing, right? But it's not labeled. There's a tick mark there, but there's no mark on it. OMG. We could find it, though. I think I'm going to go to a negative cosine. I just need to figure out what that x value is. How are we going to do that? Well, we don't necessarily need a sacrificial axis. We know that that point right here that's unlabeled is 1/4 of a cycle distance away from pi sevenths, right? What is the period? What do we discover the period to be? Thank you. 8 pi sevenths. I'll make sure she gets it again. 8 pi sevenths? What's 1/4 of 8 pi sevenths? Divided by 4. What's 1/4 of 8? No, there's a couple ways. 1/4 of 8 is 2. So 2 pi sevenths is your quarter cycle counting interval. You can either do that. These are 2 pi sevenths away. So what's 1 pi sevenths plus 2 pi sevenths? 3 pi sevenths. That's one way to do it. Another way to do it is you know that that critical value is going to be the midpoint of these two here, right? How do you find the midpoint of two numbers? The average of them. So what's 1 pi sevenths plus 5 pi sevenths? 6 pi sevenths. What's half of 6? 3. Or you could pick up on the pattern of that's a 1, that's got to be something, that's got to be a 5, and you can realize in this case you're just counting by odd pi sevenths. So now you know it's 3 pi sevenths. You could say it's minus 3 pi sevenths. Now, just to be thorough, let's go ahead and write one for positive cosine. What name could we give to positive cosine? Hank. Hank of X. Positive 5 cosine, parentheses, 7/4, parentheses, x, plus or minus something, plus 1. Positive cosine needs to start at a high point. Where would a high point be? Negative pi sevenths, right? Because how far apart are my critical values? 2 pi sevenths. We already established that. And if I go left one critical value or right one critical value, I'm at a high point. So pi sevenths minus 2 pi sevenths is negative pi sevenths. And so if I wanted to get over to negative pi sevenths, would it be plus or minus pi sevenths? It'd be plus if I want to go to the left. Or I could go right, and it'd be minus. What would the next one be to the right of 5 pi sevenths? 7 pi sevenths or pi. Yeah, so you could also do x minus pi for your horizontal shift. There you go. Not so bad, huh? When you have an equation like we did on Friday, you get the b value from the equation. You convert it to the period so that you could sketch the graph. When you have the graph, you get the period, and you convert it to a b value so you can put it into the equation. The p and the b value are closely related, but they're not the same. You get b from the equation and p from the graph. All right, any questions on Billy Bob Joe, Hank? No? Okay. Well, let's return to the notes then. We'll get more practice with that. You'll have one like that on your quiz tomorrow. 5.4, sinusoids. All right, we're on example 12, and then we got 2 graphs to write equations of. Example 12 is going to be another one of those fun ones where the critical values are kind of messy, which means they're kind of fun. Sketch at least one cycle of this function. Label the critical values, blah, blah, blah. Okay. What's the parent function? Sine. That's pretty easy, right? Once you identify the parent function, you look to see if it's in standard transformation form. Is it? No. So that's our next goal. F of x equals the negative 2/3 in front. Does that go to the back? No, that's your a value, right? Negative 2/3, sine of parentheses, and then leave some space, and then -1. So really the only work is in the inside again. Remember, you have to have your x term first, and it is, but then you have to factor out its coefficient. What's the coefficient of x? 2/3. So I got to factor out my 2/3. And I am left with x plus, now what do you get when you factor a 2/3 out of a pi thirds? Pi halves. Good. And for those of you who don't know how that just happened, here it is. We're starting with the pi thirds, and we are dividing out, that means factoring out, a 2/3. What you're starting with divided by what you're factoring out. And then you could stay, change, flip, right? Pi thirds times 3 halves. Your 3's divide out, and you're left with pi halves. When you factor out, you're dividing out. And of course, once you do that and you put your pi halves there, you can mentally redistribute and see if you get the right answer. Very good. So now that we have that, we can kind of come over here, get our stage notes, the absolute value of A, the absolute value of B, C, D, P, and then R. We get all that going down there so that we can help ourselves sketch the graph. All right, what is the amplitude? 2/3. Now, because it's negative, what notes should we put to ourselves? Flip. Good. How many cycles are we going to see between 0 and 2 pi? 2/3. Also good. That's your B value. If that were a negative B, what would we do? Would we get rid of it or bring it out front? Bring it out front because sine's an odd function. But it's not negative, so it's 2/3. Now, once I find B, I like to find the period because it's closely related. Remember, the period is 2 pi over the absolute value of B. So what's 2 pi divided by 2/3? Pi thirds? Well, let's try it. 2 pi over 1, stay, change, flip, it would be 3 halves, right? Dividing by 2/3 is the same as multiplying by 3 halves. You get 3 pi. Now, 3 pi makes sense because remember, we saw only 2/3 of a cycle between 0 and 2 pi. That's not a full cycle, so you need to go another third of 2 pi to see the full cycle, which is another pi. So it all makes sense. What's our C value? Come over here to standard transformation form. Left or right pi halves? Left pi halves. Remember, it's the opposite of what it would look like. So left pi halves. And then our D value is our sinusoidal axis. It's down 1. Now the range. Remember, the range helps us sketch the graph. The range is going to be your D value, which is -1, minus the amplitude. What's -1 minus 2/3? -5/3? -1 minus 2/3? -1 is the same as -3/3. Minus 2/3 is -5/3. And then -1 go up 2/3. What's -1 plus 2/3? It's -3/3 plus 2/3 is -1/3. Yeah, so we're kind of staying in a small little window just below the x-axis, right? Okay, I think we're ready to sketch it. I'm going to come over here and draw my y-axis. And my x-axis, since I'm negative, I'm just going to draw it a little bit higher than usual. Something like that. Now remember, if there's a phase shift, and there is, you want to get your x-axis kind of coordinated off to the side somewhere. That's when you want to make that what I call a sacrificial axis. So here's again how you could do it. Here's 0. You go out the length of one cycle, which is 3 pi. So 0 is your y-axis. Half of 3 pi is 3 pi halves. That gives you your half cycle interval. I'll use a thinner tool here, 3 pi halves. And then half of that is what? Half of 3 pi halves, or a fourth of 3 pi would be 3 pi fourths. That's your quarter cycle interval. If you have your period, you can just divide it by 4 and get your quarter cycle counting interval. Or you could bisect it twice. I like to bisect it so that I can kind of see the spacing. So 3 pi fourths, again, is the most important number on this graph. Every axis, high axis, low axis, high is 3 pi fourths away, pre and post shift. So what would be that next critical value? 3 pi fourths, that would be 6 pi fourths. This would be 9 pi fourths. And then, of course, 12 pi fourths. You keep adding 3 to the numerator. Now, those are the values pre-shift. Which way are we heading? Left pi halves. Oh, my gosh. All right, so here we go. Pi halves is the same as how many pi fourths? Because we're talking in terms of fourths, sir. It's 2 pi fourths. So notice on my scale here, 2 pi fourths is not quite one critical value. So if I come over here, here's my new y-axis at negative pi halves. Because that's 0 minus pi halves. What happens to 3 pi fourths when I subtract pi halves? Well, what's 3 pi fourths minus pi halves? It's the same as 3 pi fourths minus 2 pi fourths, which is what? 1 pi fourths. 1 pi fourths is positive, so it's going to be right there. And that's really all you need. All you need really is at least one critical value to the left of the y-axis and one critical value to the right of the y-axis, because it establishes two things. First of all, it establishes your distance between your two critical values. Okay, and that spacing you need to preserve. But it, more importantly, probably establishes the distance between the y-axis and your critical values, which has to be to scale. So notice the first critical value to the right of the y-axis is half as far away as the first critical value to the left of the y-axis. You see that? So when you're drawing your final graph, pi fourths, whatever distance you call it, pi halves needs to be twice that distance away on the other side. That's really all you need. You get one critical value to the left of the y-axis, one critical value to the right. So here we go. I'm going to put my final values down, and I'll use purple nurple here. Pi fourths. I'm going to put the smaller one down first. I'm going to call that pi fourths. So notice the distance that I have there, I'm now going to double that distance and call that negative pi halves. See that? Now that distance between my two purple marks, that's what I want to try and preserve as I continue going out to the right. Something like that. And maybe one more over here since I have room. And one more over here, last one. Okay, so this distance here is half of that distance there. And the total distance between them is what we preserve. That's what I'm going to be looking for when I grade your test. That takes a little bit of planning, and that's why we do a little rough draft first. Now it's time to label them. How far apart are all these critical values? Well, they're a fourth of the period, so they're 3 pi fourths away. So now all you got to do is go through and label them. 1 pi fourths plus 3 becomes 4 pi fourths, which is pi. 4 plus 3 is 7 pi fourths. And then you get 10 pi fourths, which simplifies to 5 pi halves. And then 13 pi fourths. And then 16 pi fourths, which simplifies to 4 pi. And then 19 pi fourths, so on and so forth. Why are we adding 3 pi fourths? That's your quarter cycle counting interval. Pre-shift and post-shift. That distance between your critical values stays the same because it's a isometry. It's a rigid transformation. You pick the graph up and you move it. Left pi halves. All right, what would be the next one to the left of negative pi halves if I go over 3 pi fourths? 3 pi fourths plus pi halves, which is 3 pi fourths plus 2 pi fourths, is 5 pi fourths. Yeah. So there you go. As long as you have one critical value, again, to the left of the y-axis and to the right of the y-axis, and you know the distance between every critical value, you've got it. That's all you really need. So is 0 a critical value? No, it's not. Okay, so we're not going to put one there. So pi halves, remember, is your new y-axis. If you sketch by the Sahala-Chala method, you need to know where that's at. So we did the hard part first, or the fun part first, I should say. We did the x-axis. We got it all marked up. Now the boring part, the vertical axis, it's going to be from negative 1/3 to negative 5/3. So I'm going to come down here and I'm going to call that negative 1/3. And if that's negative 1/3, then I got to try to keep that the same. 1, 2, 3, 4. This might be negative 5/3. And then, of course, right in between them is negative 1. So you can bisect that. So your x and y scale aren't the same as each other, but each one is scaled relative to itself. So there's your y-axis. Once you have your new x and y-axis drawn that's all labeled, high, low, midpoint, and all your critical values, that axis can now accommodate either a sine or a cosine. So now we return to our equation and we look to see what it actually was. It was a negative sine. So we need to start where? High axis or low? We need to start on the axis and head where? Down instead of up. So you come to your intersection of your x and y axis. There's your axis. And the next critical value going to the right is not high, but low. So that's going to be at, and I'm going to move my negative 5/3 over here to the other side so it doesn't interfere. It's going to be right there at pi fourths, negative 5/3. And then I'm back to the axis at pi. And then 7 pi fourths is high. 5 pi halves is axis. 13 pi fourths is low. 4 pi is axis. 19 pi fourths is high. And then working backwards, we're at a high point at negative 5 pi fourths. And if you labeled your axes correctly, these should all be pretty much the same distance away from each other. And you should see the symmetry then when you connect the dots with quarter cycle arcs. Oops. And the last one. Turn the corner, draw an arrow. It keeps going. Turn the corner, draw an arrow. So we drew 2 full cycles there of the graph. I have a high point that I'm starting at to another high point at 7 pi fourths and another high point at 19 pi fourths. I'm going to require you to sketch at least one cycle, remember, and have at least one point to the left of the y-axis, unless stated otherwise. Okay, once we have that equation, we can write an equation in terms of either a positive sign or a plus or minus cosine. Let's just pick one of the other 3. You want to do a cosine? Let's do a cosine since we started with sine. You want to do a positive or negative on this Monday? Positive or negative on a Monday? Let's do a positive cosine on a Monday. Good. So I'm going to go ahead and set up my equation. I'm going to call it g of x. And a positive cosine is now going to be a positive 2/3 cosine, parentheses. My b value stays the same. The only thing that changes up besides the plus in the front is the phase shift. So I leave the x plus or minus blank. And now as a second task, because we want a positive cosine starts where? High. So where's your favorite high point? We have 3 of them listed. At what x value? 7 pi fourths. Good. Not a bad one. So in the equation, would it be plus or minus 7 pi fourths? Minus. I got to get over to the right. So it's minus 7 pi fourths. It could also be minus 19 pi fourths if you wanted, right? Or if I wanted to get over to negative 5 pi fourths, it would be plus 5 pi fourths. So all 3 of those would work. Okay, cool. What would it be if I wanted a positive sign? I won't write the equation, but if I wanted to shift over to a positive sign, it would be x minus what? Positive sign is on the axis heading up. X minus pi, right? That's where I'm on the axis going up. Or x minus 4 pi. I have that one drawn too. Okay, questions on sketching the graph from the equation. We worked 2 examples where the horizontal shift was picked up and set down in new values. And on your final graph, I don't want to see anything but the final critical values labeled. So if you have to go off and do a rough draft sketch, that's fine. Remember, what you're looking for is the quarter cycle counting interval, which is always a fourth of the period, and where is your first point to the left of the y-axis and where is your first point to the right of the y-axis. That again establishes the distance between your critical values and the relative spacing off the y-axis. Okay, now like the warm-up, we're going to write equations from the graph. For each of the following, write a sinusoidal equation in terms of sine or cosine. Okay, there's a graph. Is that a graph of sine or cosine? It doesn't matter. It could be either one, right? They're both sinusoids. Notice there's very few things that are labeled here. What we want to do is gather the information. We want to gather our A, our B, our C, and our D, because that's ultimately what we need for our equation. But as I mentioned in the warm-up, we don't get the B directly from the graph usually. Rather, we get the P. We get the period. Okay, so let's see what we know here. We know that it's labeled at a high point at 212, and there is an axis point labeled here at 11.5. What's the easiest letter to get just looking at the graph? D is the easiest value because it has the sinusoidal axis labeled at 5. That should be your D value, right? So you know D is 5. Your C value, you're going to hold off on the C value until the very end because that's your phase shift. And that's going to depend upon whether you're calling it sine or cosine. So let's see if we can figure out the A value now. Once you know the D value, the A value is the distance from the sinusoidal axis to either the high or the low. Well, I have it labeled here, right? How far is it from 5 to 12? 7. So that should be your A value. So that's the low. What's the low point then if you wanted to finish labeling it? -2. 5 minus 7 is -2. Good to know. Now the B value, again, we don't get straight from the graph. We have to get the period. The period's the length of one cycle. I only have 2 X values labeled, so I have to use them. How far is it from 2 to 11? 9. So 9 units represents what fraction of a cycle? 3/4. Good. Here's a quarter cycle, there's another quarter cycle, and there's another quarter cycle. So that represents 3/4 of the period. See that? If 9 is 3/4 of the period, how would you solve for the period? Multiply both sides by 4/3. So it would be 9 times 4/3. And of course, you probably want to divide first. What's 9 divided by 3? 3, and 3 times 4 is 12. There's the period. As long as you know some multiple of a quarter cycle, you'll be able to find the period every time. So does the 12 go in my equation? Is that my B value? No, that's my period. So once I know P, remember P is 2 pi over the absolute value of B. So again, as I mentioned in the warm-up, B is 2 pi over P if you just solve. So if P is 12, the value B is 2 pi over 12, which is pi 6. Good. So there's your B value. So really, we can measure now all of these values. If the period is 12, what's the quarter cycle counting interval? What's a fourth of 12? 3. Okay, so we're counting by 3. So if you want, you have an axis point, a high point at 2. You have an axis point right there, which is going to be what? If they're 3 units apart? 5. And this low point here is going to be at 8. And then, of course, 8 plus 3 is 11. And then the next high point would be at 14. So you can label your X values. Once you know the period, divide it by 4 to get your quarter cycle interval and just start counting. Now that everything is labeled, it should be pretty easy. Let's call this one Y equals. Plus or minus. Let's start with plus or minus. Plus, okay? The amplitude is 7. Sine or cosine? Sine, okay. So 7 sine, and then the b value goes next, pi 6. Open parentheses, x plus or minus something, something, and of course plus 5. So once you have all the information, it's just dropping it in. You have pre-mixed bowls, you just drop it in and stir, really, for making this recipe. Positive sign, you're looking for what? An axis point going up, which would be at where? 11, right? We label it. So there's your axis going up. That's positive sign. So is it plus or minus 11? Ooh, I put plus. Is it minus? Yeah, it's minus. Good. Since we did sine, let's go ahead and force the other one to be negative 7 cosine. Still going to be a pi 6, x, plus or minus something, plus 5. A negative cosine starts where? High axis or low? Low. Very good. A negative cosine starts low. Do we have a low point labeled? Yeah, at 8. So is it plus or minus 8? Minus 8. There you go. You can keep going. All right, I'm going to give you all a couple minutes to do B on your own. Write one in sine, write one in cosine. Make at least one of them negative. Give you 3 minutes. A, B, C, D, P. All right, let's see how y'all did. We have very few things labeled here. Vertically, we have a high point at 6 and a low point at 5. Those horizontal dotted lines are not asymptotes. Because remember, horizontal asymptote describes the end behavior. And this graph is not tapering off approaching 6 or 5. It's oscillating between them. They're there just to show the guidelines. So if the high point is 6 and the low point is 5, what's the distance between 6 and 5? 1. Is that the amplitude? No, the amplitude is not the distance from high to low. The amplitude is half the distance from high to low, right? because there's a sinusoidal axis that runs right through the middle. Okay, so if you draw something right through the middle, there's your sinusoidal axis. So what would the amplitude be then? 1/2, and what would be the D value? Well, it'd be 5.5. Yeah, and if you want to go with decimals, that's fine. 5.5 works, and you can go with 0.5 for the amplitude. Okay, so there you go. There's that. No, 5/2 is 2.5. 5.5 would be 11/2. All right, then we have some x values labeled. How far is it from 15 to 100? 100 minus 15? 85. And that represents what fraction of a cycle? We have a high point and a low point, so it's a half cycle. So that's half the period. So if 85 is half the period, what's double 85? 170. So if the period is 170, whew, now we can find our B value. The B value is 2 pi over 170. What's 2 pi over 170? Pi over 85. Yeah, pi over 85. So now we're ready to go. Remember, the C value comes from whether you want to call it sine or cosine. Let's do one more thing here. If the period is 170, then what's your quarter cycle counting interval? What's a fourth of 170? It's half of 85, which would be 42.5. So all your critical values are 42.5 away. So from 15, that's a high point. We have an axis point here. That's going to be 42.5 plus 15, which is going to be 57.5. Yep. And then we have the low point, which is at 100. And then we have another axis point over here, which is at 142.5. And that might be enough to label. So here we go. The y equals, let's do a positive sign. The amplitude is 0.5. Sine of our B value comes next, which is pi 85ths, times x plus or minus something. And then our amplitude is plus 5 or the D value is plus 5.5. And now for a positive sign, we shift over to what? I have one showing. Positive sign, it starts where? Axis going up. Yeah, so that's at 142.5. So it'd be minus 142. Oops. I have too many parentheses there. There we go. Minus 142.5. And then let's do a negative cosine again. Negative 0.5. Cosine of pi 85ths, parentheses, x plus or minus something plus 5.5. And then what's the cosine? It starts where? Low, which is at 100. That was given. So it would be minus 100. Okay, there you go. So on the warm-up, you saw that I only gave you a quarter of a cycle, or a half cycle. I think there's one on the worksheet where you're only given a quarter cycle. Remember, that's all you need. As long as it's a full multiple of a quarter cycle, whether it's a fourth, a half, 3/4, a full one, or even more than that, as long as it's a multiple of a quarter, you could figure it out. You could figure out the period. And remember, the period then you convert to the B value to put into the equation. That's it. We're done. Worksheet is due tomorrow. We'll quiz tomorrow. We'll have 2 questions. I'll give you one equation, and you'll sketch the graph. And then I'll give you one graph, and you'll write an equation. Okay? Any questions?